In part 2 of section 4.1, I want to make you aware of just a couple of special types of finding a common factor. Before I get into the first type that I want to talk about, let me just give you a problem very similar to some problems that we've already done. If I gave you this 3xy plus 2y, and I asked you to go through and factor that, as you take a look at that, you can see that in both of those terms, I have a common factor of y. So if I wanted to go through and factor this, I could factor a y out of both of those terms. In the first term, I would be left with a 3x. In the second term, I would just be left with a 2. So it would factor down to y times, in parentheses, 3x plus 2. So I'm going to write another one that looks a little bit different than the one that we just did, but really it's exactly the same thing. Here I have 3x times, in parentheses, a plus b plus 2 in parentheses a plus b. And I want you to factor that. I want you to notice once again that both of these are really the same. The very first one I have 3xy. This one I have 3x times a plus b. The a plus b kind of replaces that y. The same thing in the second term. I have an a plus b, which kind of replaces that y. So if you think about it that particular way, what I can do is I can factor out an a plus b in both of these terms. In the first term, if I factor out a plus b, I'm just left with 3x. In the second term, if I factor out the a plus b, I'm just left with a 2. So my answer is a plus b times 3x plus 2. In order to finish this problem off, I just need to put parentheses around the a plus b because I'm multiplying the entire a plus b times the 3x plus 2. Here's another example very similar to the last one. In this one, I have a common factor of a minus 2b in both of these terms. So I'm going to factor out my a minus 2b. In the very first term, if I factor out that a minus 2b, I'm left with 7a. In the second term, if I factor out my a minus 2b, I'm left with 3. Once again, I need to put the a minus 2b inside the set of parentheses because it's a minus 2b times that 7a plus 3. So my final answer is exactly as I have it written, a minus 2b in parentheses times 7a plus 3 in parentheses. The last type of factoring that we need to do in this particular section is called factoring by grouping. So let me give you an example. If you would have the expression ax subtract ay plus bx subtract by, I take a look at all four of those terms, and I don't seem to have a common factor at all that's present in all four terms. So you can go through, though, and you can separate these into two different groups of terms. First of all, I have ax minus ay. And if I have ax minus ay, I can go through and I can factor an a out of that. So factoring an a out of those first two terms, I have x minus a. In the second set of terms, I have a common b. So I can go through and factor out a b out of those, and I'm going to have b times x minus y. Remember to put the plus sign there in between. And now it's just like the last problem that I did. I have a common factor of x minus y in both of those. So I can factor an x minus y out of that first term. I'm going to be left with an a. I can factor an x minus y out of the second term. I'm going to be left with a b. So my final answer is x minus y times a plus b, with both of those being in parentheses. Here's another example of factoring by grouping. Remember, I'm looking for common factors in each of the different groups of terms that I have. In the very first two terms, it looks like I have a common factor of x. So I'm going to factor an x out of both of those two terms, which leaves me an x minus 2y. In the second one, I have a common factor of 3. So I'm going to factor a 3 out of both of those, which once again leaves me an x subtract 2y. Usually when doing factoring by grouping, you are going to get two of the factors being exactly the same, which then I can factor out again. So I can factor out an x minus 2y in both of those terms. In the first term, I'm going to be left with an x. In the second term, I'm going to be left with a 3. So I get x plus 3. Putting the first one inside that set of parentheses, I get x minus 2y times x plus 3, also in parentheses. I'd like to do one more example just to point something out that's very important. This is another one that's being done by factoring by grouping. So I'm taking a look at my first two terms, and taking a look at those, I see that I can factor out a 6. So I get 6 times x subtract 2. When I take a look at my second group of terms, I have a 2xy minus 4y, and I can factor a 2y out of both of those, leaving me again with x subtract 2 when I factor out that 2y. Now that I have my common factors in each of these terms of x minus 2, I can factor an x minus 2 out of the first term. Here's the first term right here. I'm going to factor an x minus 2 out of that. I'm just left with 6. I'm going to factor the x minus 2 out of the second term, and I'm left with 6 plus 2y. So I have x minus 2 in parentheses times 6 plus 2y. But remember, it's always important to factor completely. And I take a look at this second factor that I have here, and I notice that in that I can factor out a 2 also. So my final answer for this is really x minus 2 inside the set of parentheses. I'm going to factor a 2 out of that second term, the second factor that I have. When I do that, I get 3 plus y, and it's times 2. So I really, for my final answer, have 3 different factors: x minus 2, 2, and 3 plus y. Oftentimes in the answer book, you would see the 2 come first, followed by the other 2 sets of factors. So I will rewrite it that way. Section 4.1 is a very important section and really introduces the main ideas that you will find in all the different parts of Chapter 4. As always, please do not hesitate to contact me if you have any questions. Thank you.